Alright, in this tutorial we're going to go over how to simplify expressions using the powers of monomials. So whenever you have powers of monomials, it just means you're taking a monomial to an exponent and then raised to another exponent outside of that. So those coefficients get the exponent just like regular, and then the exponents follow the power rule of your exponent properties, and they are multiplied together. Now, I had a previous video from the last unit going over the power rule of your exponent properties and how you are actually going to be multiplying them together. But after this first example, and maybe even after the second one, you should kind of get the hang of it and retouch your base on the power rule of your exponents. So to simplify this expression, notice how inside your parentheses is 8n to the fifth p squared, and then outside of your parentheses, that entire thing is being raised to the second power. You can think of this exponent as being distributed to everything, but it needs to follow your same rules as exponents. So this 8 gets squared. This n to the fifth gets squared. Let's try that again. This n to the fifth gets squared. And this p squared gets squared. So your 8 squared becomes 64. Whenever you have a power raised to another power, you're just multiplying your exponents together. So 5 times 2 is 10. And p squared, 2 times 2 is 4. And there are no other like terms that you can combine. There's no negatives that you need to move to the denominator. That expression is simplified. Same thing with the second one. 10m to the seventh n squared is all inside the set of parentheses. And then you have a 2 squared on the outside. So your 10 gets squared. Your m to the seventh gets squared. Then your n squared gets squared. So 10 squared is 100. 7 times 2, because we're following our power rule of our exponents and multiplying them together to get 14. And likewise with the n, 2 times 2 is 4. No negatives, no like terms that we can combine using our product rule, so that expression is completely simplified.